my slide?
Yes, we can hear you and we can see your slides.
Okay, awesome. Yep. Good afternoon, good evening, maybe good morning, everybody. My name is Pasang, and yeah, I'm a SFU graduate, and I'm working with Diligent, and I've been in the company for around 7 years, I would say. And been working as a developer for last about 4 years. Yeah, and that's pretty much like, a short introduction on myself. And today's topic that we're going to cover is data engineering in AWS. And so let's get started. Yeah. Yep. So just like to, set the expectation for today on and some housekeeping around today's session. So we're gonna go over some high level concepts on data engineering using AWS. It's not going to be a hands-on session, so it's more of a presentation and just talking about various things. And for audience, whether you're like beginner, intermediate, advanced, no matter what job roles you're in, like whether you're a PM or a software developer, data analyst or anything, I mean, it kind of like, it's relevant to everybody. And some housekeeping, like for the interactions is please feel free to pause me anytime and ask questions. If you want to make some comments, please do. Yeah, and if I keep rambling on and, if I'm talking too fast or if I'm going over some slides too fast, please, you can pause me anytime. So, yeah, and the biggest takeaway from today's session is to understand, like, what is data engineering and why is it like, needed, right? Like, what's the importance behind like data engineering? So this is the key thing, and like, some of the AWS services that are kind of centered around these type of like solutions. So yeah, the key takeaway is this, and if anybody stops you in the street, and asks you like, hey, what is data engineering? Or like, what sort of solutions are there in AWS? You should be comfortable, kind of mentioning like few sentences about it and talk about it, right? So that's the key takeaway. We've already have a question in the chat. Okay. So let's start with, so there is a company. So I'm going to start with the short story, like any presentation. So we have a company that just launched their first product, right? And everybody is super excited that they've launched their first product. And before launching the product, the company has like, kind of pre-thought about things like, okay, we are data-driven organization. We need like, before launching our product, we need some like, business insights into like how our customers are using the product. So like, all the stakeholders in the business are making like assisted like product decisions about their next move and their next strategy, right? So so with that, they pretty much have a data analyst who basically gives all these insights, like, getting all the KPIs for the business and to kind of like, give them an assisted like decision-making capability, right? So this data analyst is, you can imagine like he's, well, she is like, working on creating some like dashboards, like reports and things like that. And she's pulling data from different like, external sources from like CRM, like from, from the application database that they have, right? And she's like, working very hard to generate these reports and analysis, right? And, this is the like, she kind of gives these like analysis to the stakeholders, and they like the stakeholders have their like weekly meeting, their monthly, quarterly meetings, and they go over all these like metrics, and it helps them drive the business forward and to make like assisted decisions centered around data, right? So everyone is happy. Things are going smooth. They're making like good decisions. um, and just a few months later, there are some like very concerned developers because they've been seeing some like alerts in their channels. There's also some customer complaints that have been captured, that the customers have seen like some degradation like in the application like side as well into some features. And also like there are some like security personnel like working in the company who have kind of reached out to like point out that there's like some sort of sensitive data that's been like retrieved by like the data analyst, which is like not something you would do, right? And even the data analyst herself, like she's working hard, and she's experiencing very like slow analysis, and like it's not she's not getting like reliable results, and she's not able to generate these reports and like things in time, which might affect the stakeholders meetings, right, that they might have to like postpone because they don't have the numbers to discuss. So this is like what happened. And so this kind of like goes on for like a few weeks per se. And the data analyst needs some help, and she basically turns to the developer team, and she reaches out a developer, and then they start talking about this problem, right? And in this like discussion, the developer is asking like what sort of things she's doing, right? And they're kind of discussing about this. And I mean, no surprise, like she is running an analysis query on these like OLTP like systems, right? And most importantly, like these OLTP systems are like line of business applications that are like using it. So that's what she's doing, and all of this madness is like coming out of this like this issue, right? So now like we get into talk about OLTP and like OLEP systems. So the difference between like OLTP and OLEP systems, like as described in this table, the different characteristics of like how you use it. Usually like you have the OLTP for like transactional like purpose that are used by your line of business applications, right? Your applications are using this. And the OLAP type of like queries that she was running is more for like like analytics purpose, right? And the priorities in OLTP system is that like it's more prioritized for writes, because like just the type of like request that is coming is very different from OLAP system, right? In OLTP system, you might have like very like many requests, but they are dealing with like small subset of data, right? And in the OLAP, usually you have like many like you're kind of dealing with like huge like amount of data, but then you have like you might have like very low number of requests coming in, right? And also like these differences between the OLTP and OLEP, this is a very oversimplified like generic like differences, right? There are systems that like kind of support like both, and we don't want to get into like that kind of complexity, but in general, like what you should know about like these differences are this. And yeah, like for response time, like the OLTP system, like it's serving your line of business application. There are many requests coming, and you're dealing with small subset of data, so you want to have like fast like response time. So usually it's in like milliseconds, right? And for OLAP, it can go for like, minutes to hours and like, I don't know, like days even for like, some crazy like queries. And usually, yeah, like I already mentioned, the size is like, uh, the OLTP like databases, like, usually like, for a fairly like sized application, it might be in gigabytes, but once you get into OLAP, like, you kind of get into the terabyte and petabyte scale, right? And the type of data, like, how you store the data is usually like in OLTP system is usually normalized to eliminate redundancy, right? So kind of like you work out your database design and you kind of keep like normalizing the data. So because like, writes and updates are important, right? Because they need to be fast. And so you want to like normalize them so that you don't have like, you don't need to like update like many times, right? Because there's like not many redundancy in your system. Whereas like in OLAP, like it's generally denormalized. And this is more for like, because there's not a lot of like, writes and updates that are happening, but it's more for like, like doing complex like analysis. So yeah, so we talked about like, the type of like queries that the data analyst was running were more related like, OLAP type of queries, right? So how do we like, kind of get into this system? Like how do we make like, these OLAP queries like more efficient, right? Like, so what type of like, data should she be querying on, right? That's when we like kind of get into like, things like ETL, right? So this is a like, a basic like format of what an ETL process looks like, right? And the crucial thing to understand here is like there's, I mean, extracting the data from different sources and you're transforming the data. So you might be like, transforming this data into some like efficient format that the data analyst can run like, this the analytics queries on, right? So basically you're kind of like transforming the data to make it efficient for these type of queries. And so that's where you do the transformation and then you load the data into some storage. And that's where like, the data analyst can query from, right? So that's what they kind of did. And like, so they saw like, this weaknesses like, and they actually like perform these type of actions. Yuri, you had a question?
Not me, actually. We have questions in our chat, and one of them, it's not question, it's kind of just statement. You could say OLAP is the most times not online data. Eventually, it will catch up with OLTP systems. And question, Denise is asking, is it similar to CQRS architecture?
I'm not sure what is a CQRS architecture. Maybe like if you know the CQRS architecture, maybe you can like define it, Dennis.
Yes, it's when you use two models, two databases, one for change your data aggregates, and it's always normalized data, and other database only for queries for read data. It's usually denormalize it and optimize it for queries for different needs, maybe for analytics, maybe for marketing, for different departures, departments.
Yeah, I think yeah, like I said, this the OLAP and OLTP, like, I mean, it's more of a like oversimplified like version of what like we should like kind of understand, right? Between these type of like systems, how it works. But like I mentioned, like, yeah, there are like, some like MariaDB, right? Like, I mean, it has like, like just like what you explained, it has both the parts of like, they have some sort of optimization done internally to support like, OLAP type of queries, right? So it's kind of like, you have like, both together in the same system, right? I think like that's where you're trying to go. command query responsibility segregation. So yeah, so I think like there are more like answers and reply to like previous questions related to that. Yeah. Okay, so I'll keep continuing on. Like, unless like, is there any questions so far?
Just a comment, actually, when you were talking about the properties in the previous table.
Yeah.
I just mentioned maybe another property, because I know that OLAP systems, usually you are concerned about query efficiency, and you need kind of duplicate data, and it means that maybe the data you have there is not as update as you have in a OLTP data.
Yes.
Kind of system. So usually we have like this trade-off.
Yes. Yeah. For sure. Yeah. Thanks. Yeah. So this is like, you know, a general like traditional approach of like, you know, extracting your running your data through like, you know, this type of transformations. And usually you have like, you know, like OLTP like as the source, and then like, you know, you kind of like put it into an OLAP system. I mean, this is a very general like, you know, like approach of like how people like traditionally and like even today like do this type of like, you know, transformation to get like, you know, more query efficient like system. So like, you know, so now we talked about the ETL process in general, and so now I'm gonna get into like, you know, some of the services. I mean, these are not all the services, but these are some of the services that are used for ingesting like, you know, data in AWS, right? So there's like AWS DMS. So this is the data migration service, which you know, you can not just for like ingestion, but you like, you know, generally use it even for other purposes, like, you know, for like, you know, migrating from one database to another, things like that. So I think there's more question in the chat. I think I'm not going to read the chat. Maybe like, you know, if there's like some significant question, maybe Yuri is going to raise it.
Yeah, I will raise the hand. Yeah, you can count.
Perfect. Yeah. So yeah, that's pretty much like, you know, DMS, where yeah, you can use it for data ingestion as well. Like, you know, you can use the DMS for yeah, extracting data out of like, you know, like these different data sources and like put it into like S3 as an example, right? And you also have like Amazon AppFlow. This is more of a pull-based approach, I would say, where, you know, you can create like AppFlow, where like, you know, it kind of runs like a job, and it basically like, you know, pulls the data maybe from different SaaS like APIs and kind of like brings the data into like your destination. And there's like limited number of services that are supported as a source and destination. But this is also like, you know, something you can use, right? And then you have like, you know, Kinesis. So this is like Kinesis has like, you know, whole family of different services. So there's like Kinesis data streams and Kinesis data Firehose. These are related to like your streaming data, right? So you might have like, you know, some like streaming logs, or from some IoT like sensor devices, things like that, where you're constantly streaming data. This is like the service you would use to ingest data, and for the Firehose, like, you know, you would use that to kind of like buffer your data. So your streaming applications are just like streaming, and when you write to like, you know, for example, when you write to S3, right, you might want to configure your Firehose to kind of like only flush the data into S3, like, you know, once it reaches like maybe like, you know, time wise, like in 15 minutes, or maybe if the size is like, you know, a certain size, right? So it kind of has that type of configuration, and that's what you would use like Kinesis Firehose for ingestion. And then talking about transformation, right? On the transformation side, like, you know, you kind of are looking at like compute services per se in AWS. A simple a simple service you could use is an AWS Lambda. So this is like, where this is a completely serverless like compute like service where you can pick different types of like engines you want to run it on. So like, you can pick Python, like Node, or any type of environment that you want to run your transformation on, right? And you also have AWS Glue. So you would use this, you would use like AWS Glue for transformation as well. It can run like, you can run like Python or your Scala code, and you can run it. And it's more of a heavier type of like, for heavier type of workload that you would use the Glue for, because it has a distributed nodes, right? So like you can, it can run your job on like, multiple jobs, whereas in Lambda you're basically running it on a single job, right? So yeah, and AWS Glue is like, completely serverless. You can pick like, certain types of like DPUs. I mean, like how many number of DPUs like nodes you want to like run your job on. And for even bigger loads, like, if you are dealing with like, terabytes of data and things like that, you might use like Amazon EMR. So this is like, it kind of gives you more like tuning like power that if you're a big data expert, right, and your big data frameworks, like you can like, use it in EMR. And yeah, it allows you to like configure more like, powerful like instant types and like, different number of nodes, and you can use a bunch of different like, frameworks like HBase and like, Hadoop and things like that. You can use like EMR for that. So for the Glue, I wanted to like, talk about Glue a little bit more, because it has a lot of pieces into it in itself. I mean, it's like purely serverless, and the entire purpose, like, behind like, what AWS is kind of doing is, I mean, there are a lot of things that are serverless, right? And they want to have like more like a like, low code to like no code type of like approach for the clients, right? And yeah, so it's kind of like, you don't like, it's kind of like abstracting away all the complexities and kind of trying to like manage things like, for you, right? So they have something called like, Glue crawlers, which basically like you can create Glue crawlers, and you can crawl, example, like you can crawl an S3 bucket, like, you can specify like a prefix like you want to crawl, and it basically crawls, and it creates like a metadata like table out of it, right? And they have like, something called Glue catalog, which is a metadata store. I mean, you kind of store your table schema and like, all the properties, like where your table data is located, like what type of data you have, like, those type of things. So basically that's what a crawler does. And so when you're crawling a data, like, it efficiently like parses the data and finds like, okay, what is the best type for this like column, right? So something like that. And for that, like they have like, classifiers, like built-in classifiers, or you can bring like custom classifiers, like you can write your own like regular expressions to like, to bring your own custom like classifiers as well. So that's what like, that is. And yeah, you can like, schedule your like, crawler to run like at any time, right? And it has like, the main thing, which is the Glue job, which you can create and run. And it basically runs in a like, Apache Spark environment. You can also run it like a Python shell job, like as a single like, single node like Python shell job as well, for like smaller like workloads. But yeah, like you can it has the power of like, a distributed node, like, for parallelly processing like huge files. And that's pretty much like, you know, what you would use the glue for. So on the storage side, you have like, you know, S3 glue data catalog, which I kind of like mentioned briefly. So around S3, like, you know, it's an AWS service to like, you know, where you can store your files. It's an object storage, and it has like, you know, all these. I mean, all of these services have like, you know, like security and everything like, you know, ingrained like into the service. And there are like, you know, many like additional features around S3 that are very helpful. And you have the Redshift, like, which is like, you know, the core data warehouse like in AWS, right? So I mean, anytime you like talk about data warehouse like in AWS, you will end up in like you will end up seeing Redshift like everywhere, right? So yeah, so you can like, you know, use the Redshift as like storage, so you're kind of storing data warehouse like purpose data into it. And on the consumption side, like, you know, you have Athena, which is basically your serverless like, you know, query engine. You can run like your ad hoc queries on Athena, and it can like, you know, basically like query like, you know, your S3 bucket data, right? So yeah, so for in like a data lake approach, like your fastest way to kind of like, you know, make sense out of some like, you know, data lake data is like Athena, because there's no like, you know, there's no configuration at all. Like, you know, like you just need to create the metadata. For example, like, you know, you can like have a crawler crawl your like bucket, right? Like your prefix, it'll create the metadata, and you can start using Athena and like, you know, just query this data using Athena. And AWS QuickSight, this is like, you know, where you would like create your dashboards and all those like, you know, reporting related stuff. And you can hook it up with Athena to like, you know, to create your dashboards. Yeah, and you have Redshift. So on the consumption side, like, you know, I put Redshift here as well because yeah, you can like, you know, the QuickSight, you can hook it up to like Redshift as well. And like the Redshift is like, you're storing the data, but at the same time, like you can also use Redshift to kind of jump over to your S3 bucket data, right? So they have something called Redshift Spectrum, which basically helps you query like, you know, additional data that is like, you know, in your S3 bucket. So that's like, you know, it's an example where you might have like, you know, cold data, like, you know, some historical data that are not frequently accessed, and they're in the S3 bucket that you have kind of archived somewhere, right? So you can like, you know, use Redshift to query those data. And yeah, some examples like, you know, this is just I'm just like, you know, listing like some of the many services like SageMaker, like, you know, you can use for like building like different like machine learning models out of this service. And, you know, you can use like the data in S3 bucket and hook it up with the service and yeah, like build your models. So putting it kind of like, you know, into this flow, like this is where you kind of have like, you know, different data sources. And, you know, for batch jobs, like, you know, you may use like Glue or DMS. And yeah, you can like, you know, bring your data in and dump it into raw bucket. Or for streaming purpose, like I mentioned, you can have like Kinesis and Firehose and put that into the raw bucket, right? By the way, do you see my cursor? Yeah, okay. Yeah, and then so once it's in the raw bucket, yeah, and then comes the transformation, right? Where, you know, you have like various different services, like I mentioned, which you can use to like kind of transform this and optimize it for like analytics purpose, right? And put it in the curated bucket. And yeah, then it's kind of like ready for analysis, and you can kind of have like, you know, different services that are reading the curated data, right? So in this like, you know, format, like we've kind of separated like, you know, the OLTP system like from the OLAP, like just for the purpose of like doing like complex like, you know, analysis. And yeah, like I mean, when you're querying, like, you know, you're not directly querying like, line of business applications, right? You kind of have a separate like storage where you, it's mainly for that purpose. And like, you just run your query on like a non-production system, right? So that's that. And then comes like, new requirements, right? So the new requirements are like, maybe the stakeholders are like, trying to hire like a data scientist for future analysis of the data, which like, they don't know like, how that data will be used, but like they will be hiring like a data scientist to like, to generate different like machine learning models and like do like, more like predictive analysis, right? And they're not just happy with like, the current data, but they want like, more a bit more advanced like decision making skills, right? So this is where like, emerges the concept of data lake, right? Because so far like, all we're doing is like you're taking the data from different data sources, like you're kind of transforming it to optimize it for like, analytics query, and you're dumping it into like, some like, another storage, right? And you're running query on it. So that's like, a bit of a data warehouse and data mart like type of patterns, right? But this is where like, you need a data lake, right? And so an example here, like, your raw bucket could be a data lake in itself, right? This is where like, you kind of bring in all sorts of data and just like put it in your bucket. You kind of organize it and put it in your bucket for like future analysis, right? That's where like, the data warehouse and the data lake comes in. And
sorry, Pascal, there's a question in the chat, Pascal, about the cost. Maybe you want to answer it now.
So the question is, what's your cost experience in this kind of ETL system? Sorry. Well, okay, for us, like, we in my experience, what I would say, right, is I don't have the exact numbers into like, what exactly was our cost, right? But like we'll kind of get into that a little bit like in one of the slides, right? But in general, like, if you're using like, things like glue, right, to kind of if you're using glue or EMR like clusters to transform your jobs, right, you might like, you might be paying a lot more, whereas like if you're using like Athena, right, for example, which is like, which is more like an ad hoc query, then like, your cost is a bit lower. And I mean, this type of like, this question also heavily depends on like how much data do you have, right? Like, how much data you're processing, right? Like, so I wouldn't be able to answer exactly like in terms of numbers, but so far, like, we haven't seen like any like huge costs associated like with the system we have. Yeah, if that kind of answers your question. Yep, thank you. So yeah, like talking about data warehouse and data lake. Yeah, so as I mentioned, like, in data lake, I mean, data is complicated, right? Like it comes with like, different like velocity, different variety, like, and data is like, like some are structured, unstructured, and like, so like in data warehouse, you put like structured data, right? So they're usually like very highly curated, and that's where you put. And in data lake, you can put like, pretty much like any sort of data, right? It can include like unstructured data, which is like, your audio files and like, like images and things like that, right? So like you would put all those type of raw data in data lake, and yeah, maybe like, you'll need it for like some machine learning purpose later, right? To like, do like sentiment analysis or things like that. So yeah, so that's the type of data you would store. So like on data warehouse, like whenever you're writing data to data warehouse, like, you know, you need the schema, right? To write the data into data warehouse. But into data lake, like you kind of like, you're just sort of, you're not creating something called a data swamp where you just like dumping the data like in a very unorganized like fashion where you kind of don't know where your data are, like but you kind of like, you know, you still structure in terms of like you know like where you like organize your data properly in like, you know, for example, in S3 bucket, right? But you could like, you know, when you're reading this data out for some other purposes, like maybe you're creating a like custom ETL pipeline in the future, right? So in that in that purpose, like, you know, for that purpose, you may like, you know, generate the schema on read, right? Like when you're reading this data for this new purpose. Usually like, you know, for the data lake itself, like, you know, mostly like, you know, I mean, it's mostly just the storage, right? I mean, like, you know, if you're pulling the data out of data lake and, you know, you're doing something else with it, right? And if you add up the cost of transformation and everything, like it might be like, you know, it might be high, but generally like you're just like, you know, kind of paying for the storage, right? So which is like fairly low. And you can like, you know, store data in like, you know, different like in S3, like, you know, you can put your objects into like different like different like, you know, storage modes, like, you know, which are like, you know, you can archive your data, right? So it's like a bit like more inexpensive. And usually for data warehouse, like, yeah, it's usually associated with a bit of a higher cost. Yeah, for example, like even like Redshift is actually like quite expensive. Because you're like, you know, if you're processing like a large amount of data, then like, you know, you might need to like spin up a lot of like expensive type of nodes, and like you might spin up like many clusters, and your cost could like, you know, go up a lot. Yeah. And yeah, for data warehouse, like, you know, you have your data analyst using it, but the data scientist may like, you know, also like get some data from data warehouse as well. But for data lake, like usually it's like for data scientists like to kind of but for the data scientists, like, you know, you kind of have to like know that, okay, what, like if you're building some models, right, or if you're using some like AWS service, like you need to know like, you know, what type of like data you need and like what type of like format your data should be in, right? Yeah. And data warehouse is like for analytics purpose, and data lake is more for like, you know, future problems that you have to solve. And like you may still use like, you know, data lake data to do like data warehousing stuff, like I mentioned with like Athena, you can just like directly query data lake data. This type of pattern also like exists. So now we're gonna talk about like, you know, layering like different modern like data pipelines. So yeah, you have like, you know, the data sources and the ingestion layer, processing and storage, like consumption. So these are like, you know, it's kind of it's important to have like these separations into like your like when you build these like ETL like services, right? Even on the AWS side, like, you know, they try to separate like storage from like processing and like, you know, consumption, right? So it kind of like gives you it has the benefit of like, you know, you're kind of separating like you're decoupling these type of like efforts into its own layers, right? So for example, like you might have like new integration like with new data sources, right? In that case, like you don't want to rewrite your processing, and you don't want to like, you know, like, you know, kind of yeah, like you want to like, you know, you want to create a single interface where like, you know, it kind of supports all these different like different types of ingestions, right? So in this case, like, you know, you might add like you might update the ingestion layer by supporting like, you know, more like other sources. In that case, like you still don't need to touch your processing, right? And even within processing, like, you know, there might be like you know, this, which is like kind of like cleaning up the data, like, you know, I mean, like you're kind of like formatting data in certain types and things like that. Whereas like in the transformation, like it could be more related to like, you know, business use case or specific need on the consumption side, right? You might like, you know, only update like on the transformation like layer, right? So this is, yeah, like I just like mentioned. So these are like, you know, some of the benefits, like when you kind of separate each like different layers into its own. And looking at the, you know, like into these like different layers, like you have different AWS services that kind of like goes into these different layers. And we kind of like talked about some of them, right? Yeah, so this is like, you know, a quick example of like, you know, you might have like streaming data that goes into the bucket, and in the glue, you can also, you may have a situation to like orchestrate different like jobs, right? That's when like you would use like, you know, things like step functions to like, you know, where one job finishes and then like, you know, it passes some like, you know, like parameters out, and then your next job picks it up and like, you know, does more stuff. So this is kind of that. And on the security and monitoring side, like as I mentioned, like, you know, all these services like come with the security and everything features of AWS. Yeah, so that's what it is. And for cataloging, this is like your metadata storage about like how your data is structured and what type of data you have. So this is like the Glue catalog. Yeah. So yeah, we kind of like, you know, went over like an ETL system, right? And like, you know, we talked about ingestion, like storage and transformation. So I think like for ingestion, like it's more usually, you know, there's not a lot of like, you know, changes required in ingestion. Like when you create your system, it's usually like, you know, it's just a one-time thing and you don't change a lot. And the same thing applies to like storage. You don't need to like, you know, often like work with these, right? But something that you like mostly work with is like the transformation, right? Like in transformation, like you might have a constantly updating like architecture, right? Like even in terms of like AWS infrastructure. So so we are going to like talk about the transformation like infrastructures. So one way of doing the transformation is a very simple use case where you're using a Lambda, right? And this is like, you know, a single job, like as in single node, like you just have one process that is like doing this conversion. And so yeah, so here, like, you know, you might drop in a file and, you know, it sends an event to like SQS. So this is simply just for like, you know, handling like your workload. So, you know, and your Lambda like picks up this job and does this transformation. You can use like, you know, if you're running your Lambda on like a Python, right? They have like, you know, AWS Data Wrangler like library, which you can use to like, you know, kind of easily do these type of like transformation, right? So this would be like more on the lightweight type of like workload, right? So like, you know, what limitations does this like impose on your like workload, right? Well, you're running on Lambda, right? So it has like, you know, like limits on the memory size that you can use, right? And it also like, you know, there's limits on like how long you can run your Lambda, right? So if you have like big files, it can only like, you know, the maximum like it can run is for 15 minutes. So like if it takes longer than that, like, you know, your job's gonna fail, right? So so we move on to the next pattern, which is like using Athena. And Athena, like I mentioned, is like serverless, and you know it's a query engine. Like yeah, and you don't need to configure anything. You can use Athena, like, you know, as long as you have a like the metadata of the table, right? And you can query like, you know, you're using your Lambda, you can query Athena and like, you know, do this like transformation if you like, you know, need to, right? So the downside to this is, like, you know, while you may run the query in Athena, and then, like, you know, you may wait for this query to be successful, right? So it's but you would have a big, like, you know, idling time in your Lambda, that your Lambda just like sent the query and it's just waiting now. Like and the Athena, like, you know, might take some time, and you're also paying for the Lambda resource because it's like running. So there are patterns where you could potentially like kind of run the query and then just kind of like, you know, you can like exit your Lambda, right? Like, and you can, like, you know, create rules, like, you know, if the query like completed, like or failed, like, you know, you can invoke like some other Lambda to kind of like manage this part, right? So this is like also another pattern of, like, you know, doing this. And there are limitations to this as well, right? So these are some of the limitations around Athena limits, which is, like, you know, the DML and DDL active queries. You can, like, I think by default you can have about like 20. I think you can update it, but I don't think it goes, like, you know, a lot more than that. So that's, like, you know, the number of active queries. So if you have like a huge workload, right, you might have, like, you know, multiple queries running, so your jobs might fail because, like, you know, you kind of exceeded that limit. And there's also, like, you know, 30 minutes, half an hour timeout on the DML, and 600 minutes on DDL. And there are some, like, you know, limitations on, like, the query like string that you run on Athena. These are some of the Athena limits. Okay. Yep. So now we get into, like, you know, glue. Actually, one thing I wanted to mention was, like, you know, once you, like, you know, once you like after this Lambda, like once you run your queries on Athena, you're already in the, like, you know, distributed node game. You've already, like, you know, kind of have like parallel processing of your data with, like, you know, multiple nodes. But this is like all on Athena side. Like you have no control over like configuring, like, you know, how it should run, right? Now, like, you know, now you have Glue, which is also the serverless, like, you know, ETL engine, and this is the core like ETL service on AWS. And yeah, like I mentioned, you can run it in a Spark environment with, like, you know, distributed loads. You can select like number of DPUs you want, right? And you basically pay by DPU hours. And yeah, so, like, you know, if you can select the number, like, you know, the type of like the number of like DPUs that you're going to be consuming, like, you know, you definitely like have to pay for any sort of configuration you picked, right? So this is, like, you know, a better choice for like a much like heavier workload. Yeah, and it also has, like, you know, the limits. So like you have like about 200 concurrent jobs that you can run, and the maximum jobs, like, so the maximum jobs is the different types of jobs. Like you can create like many different jobs that does different things, but the maximum jobs you can create is yeah, like 1K per account. And the maximum like task DPUs that you can like have is like also 1K per account. So if you're, like, you know, if you're working with like even bigger load, right? Like if you're working in like terabytes and petabytes, right? That's where, like, you know, you might use things like EMR clusters, right? Where you know your workload, you know, and yeah, you know your workload, and you have, like, you know, big data engineering, like, you know, expertise, and you can tune your, like, you know, your parameters like accordingly, and use, like, you know, EMR for that purpose, for bigger, like much bigger workloads. So now we've kind of, like, you know, talked about like transformation on the infrastructure side. Like, you know, we will get into the data side, like yeah, of the transformations. So on the data level, you basically have, like, you know, you're basically doing data preparation, which is yeah, you're basically picking like different file formats, partitioning, compression, storage optimizations, right? So for the file formats, like you basically have like, different types of file formats, like row format and columnar format, right? So you can like, accordingly like pick like which one is like well suited for you. And partitioning is where you kind of like you partition your like, files like according to like, some attribute, right? Like a date, like, a date is a very common attribute where you partition your data, right? So when you're querying, like you're only querying like, a specific subset of data, like, maybe it's like you're storing like a lot of historical data, and you want to like partition those data like, according to the date, so that you're only reading like data from specific like year or specific month, right? And you like, you want to like, compress your data as well. So like, you kind of like optimize the storage. And for storage optimization, like I mentioned in S3, like, there are features like different type of like, storage tiers that you can store your data on, right? So for data lake purpose, like if you have like super old data, you might like, kind of create like lifecycle rules to change the tier of your data into like, an archival mode that you pay less, right? So I mentioned about file formats, and just wanted to like, quickly talk about the columnar and row formats. So in the center, we have like a logical view of a table, and up top, like okay, like if we go to the bottom, which is row like format, this is how like, this table gets stored in a row level format, right? So like if you read from left to right, like, in each like chunk, there's each record is there, right? So as you can see, like, this is more it's not it's good for like, if you want to like insert new records or like, update a specific record, right? So it's because like, all you need to do is like kind of get into the block where like, you need to like update or like insert, and then you just like, just write it. But if you need to like, read and find, like filter some data, right? You would need to like, the database engines like would need to do like, more IO operations, right? Because each of the row could be like in different blocks and in the disk, right? So an IO is like an expensive like operation, so it would take a like longer time to do like, analytic type of queries, right? But whereas in columnar format, you basically store like, each columns into a single block, right? So when you do the reads, it's much more efficient, because usually like, these like queries, you're just kind of interested in like, specific columns, right? So like it would be like, a less like, hops for the like engines to actually like, pick up specific columns, right? And also there are like, so for example, like if you pretty much like, you have the same types of data into the same block, right? Because you have the same types of data, like the compression gets like optimized as well, right? Like how they compress the data gets optimized as well. And yeah, and like, and also because you're storing like, the same like column into the same block, you kind of have like there's it can have like, extra metadata, like, different stats about the column, right? Like, so that it doesn't need to be like calculated, and if somebody's reading, like it can just read the stats like from there as well. So that's where like, the columnar format gets like, more like there's like benefit to using like columnar format files for like, analytics purpose like queries. Yeah. So yeah, and then we get into like data cleansing. So when you're bringing like, data from like different sources, you like, yeah, there might be like different sources bringing like similar types of data, and you might need to change like column names, right? You might have to like change the column types that works efficiently with with the transform data, right? And like you might have like, because from different systems, like the date time or like, or any type of columns might be written in a different format. So you can like, in the transformation, like you can change it to like, a specific like standard like format. And also like, you would kind of eliminate any sort of like sensitive data, like, and or like even remove like invalid data that's like, not really needed or has like, no use in the data warehouse, right? For like, analytics queries. And yeah, like I said, like, you may have like, a bunch of like unstructured data coming from like different like places, right? And so you might have like, sensor data from like different types of sensors that are like, absolutely unstructured. And this is where, you would like in the transformation, like you would like actually like structure the data, right? And yeah, and like I mentioned, yeah, like you can also like, for you could store like, some like audio and image files, which are like, completely unstructured as well. And from there, like, you can additionally extract metadata and store it like, somewhere else, right? And data enrichment. So this one is this is more on like, when you're running like, analytics queries, it's usually like, there's a lot of like aggregations, like functions used most of the time. So this is the transformation where, you may need to like, you might want to like pre-aggregate the data, right? Like for some of the, like, for some of the tables. And there may be like, business use case transformation, like some of the records might like, mean like absolute, like, it might like give no value when you're running the analytics queries without like, without like joining it with some like, third-party source or from a different table, right? So like to add more context, like you might have a business use case to kind of like to like, join with like other types of like tables from different sources, right? So this is where like, you kind of you're bringing the value in the data, right? So that's what like, this use case arrives. And like, when you're bringing data from different like OLTP systems, like usually they like, they're like highly normalized, right? So and like, but when you're running analytics, like, you want to like denormalize those data, right? And that's where like you might join with like some other tables and create a new table. And so there's like, more of a less join on the analytics query side. So this is where like, you would pre-join like in those type of scenarios. So yeah, this is like, because we talked about like, data enrichment, and there's like different data modeling, like, it's a whole like different like, game on like having like, how to like design your data model efficiently so that these queries run like more efficiently. And this is just like, one of those examples of like where you have like star schema, right? And it's called a roll-up like type of like, model. And it's like, more of a relational type of model where you have a like fact table in the center, right? And it's kind of accompanied by like a dimension table like on the side, and it kind of looks like a star, and it's called star schema. So the great thing like, about this is that like, it kind of looks like a like, more like a OLTP type of like design, but then it's like, for example, like if you look at this dimension table, it's, I mean, it's still like, denormalized in a way, right? Because like dealer NM and dealer CN TCT, right? Like these are like, I mean, in a typical OLTP system, like this would be like further more normalized, right? Like into another table. But whereas like here for like, it's kind of like not like, not like normalized like a lot, but this is like, you know, more of a relational type of like modeling for like data warehouse data. And so the fact table is something that, you know, has the business use case about like it contains like different like metrics and numbers that the like data analyst and the stakeholders are like interested in, right? And basically, you know, and to give the context, you have the dimension table, right? So they would just like, you know, filter on the dimension table and, you know, and aggregate on the fact table, right? So this kind of like increases the efficiency of how you're like, you know, how the data analyst is like querying the data, right? So this is just like, you know, one example. There are like, you know, more patterns like Snowflake and, you know, like different types of cubes of data modeling that you can do, right? Yeah, that's what the data modeling is. And for the updates and deletes, like, you know, this is one of the biggest challenge in like data lakes. For example, you have like, you know, you're storing like S3 files, right, as your data in the data lake, and it's absolutely like, you know, it's absolutely like kind of like impossible to like, you know, because it's in a file, right? Like you would need to like, you know, kind of like update this file or like, you know, delete and replace this file, right? So it's like a huge like challenge in like in updating and deleting. So like usually like, you know, usually for data lakes, like, you know, people just like don't even like, you know, bother like updating and deleting, and you're just kind of like, you know, kind of like creating like new snapshots of the like, you know, the data like every time. So you're just daily dumping like the same data like, you know, every like day or every like, you know, week or things like that. Although like, you know, there are patterns in like, you know, where you can like in the transformation like phase, like where you can like, you know, get the current data and you can like, you know, sort of like merge it with the existing like data. And, you know, so there are like, you know, patterns like these, but then they kind of are very like complicated, and like, you know, people like try to avoid like doing these type of things. Like same thing with like Athena view, right? Like you could like, you know, get your like, you know, updated like, you know, your changed data, and then you can create a view like, and you can like join it with the updated data. But then like, you know, as more updates come in, like your update tables like, you know, keeps growing, and you might have like multiple joins, and it just gets like, you know, too complicated. And as like, you know, technology like advances, right, like people want like, you know, this is this is where like, you know, the OLTP and OLAP like it kind of like comes together, is that like people want like, you know, like transactional like feature in even in like, you know, OLAP like, you know, data lake systems, right? And this is where like you pretty much have like, you know, ongoing like, you know, work on like making these like OLAP systems like, you know, more performant even for like, you know, transactional type purposes. And that's where like, you know, you have, so in AWS, you have something like a governed table in lake formation, which kind of supports this, right? Like you can like do a row level update and like deletes, things like that. And yeah, you can like use like Apache like Hudi with like EMR and Delta Lake. And also like there's for Athena, there's like Apache Iceberg table, which you can create, which does support like, you know, these like ACID properties and row level updates and all these things. Yeah, that's and you know, like the feature like, you know, requirements are like, you know, like they keep like evolving, and then like, you know, all these like technologies like they kind of like, you know, are supporting like, you know, all types of features in like different databases. So like this whole topic kind of gets like a bit like complicated sometimes, like when you're trying to read about like, you know, if you're like a beginner and trying to like understand these topics, that's where it gets like complicated, because like so that's why I'm like, my presentation is more of a like oversimplified like concepts around like, these type of systems. But then like, the newer systems are more like, like advanced, and they kind of support like everything, right? Yeah, like I mentioned, like with Apache Iceberg, like, like you can run like time travel queries, right? Like you can literally run queries like what your data looked like a week ago, or and it supports like, like schema evolution, like how your table exactly looked like, a week ago, things like that. So yeah, and there's like, a lot more like advanced things and topics that you can check into. But in general, like, these are like, some of the AWS services like around data engineering. And that's pretty much all for my talk. Thank you for listening. I think I wanted to go like exactly 1 hour, but seems like I went a little bit over. Yeah. Any questions?
Just applause.
I have one question, so if
Yeah.
you don't mind. It's about keeping let's say online dashboards updated as new data comes in. So let's say you have a dashboard that presents data about orders sold in an e-commerce, and you want to have this dashboard where you have information categorized by age, state, and things like that from all of your selling channels, let's say. Do you have like an indication of tool or strategies for this kind of use case?
Yeah, I think like usually like I think like this can be achieved with like, okay, for most of the OLAP systems, right? Like it's like, you will have things like dirty reads, like, what you're kind of mentioning is that like, that you're updating the data, and then like, your reads are like, kind of like getting like, dirty reads, right? But I think like, if you have like if you use like Redshift, I think it does support like this type of like yeah, like this type of like pattern that you're talking about. Are you
So you kind of recommend Redshift as a first?
so okay, so
Right.
I mean like it really depends on like, what like what your app, like, how much like, what your application is, like, what type of like workload your application has, and like, how much like you will need to query, like, to support this, right? It really like depends on that. But in general, I would say like, like, yeah, you can like, I think Redshift like does support this.
Ooh, nice. And another question, so if you don't mind, it's I'm just thinking on the use case of Spotify, that when you get to the end of the year, you get this kind of retrospective of your year, right? And just wondering how you can use this kind of analytics processing to deliver dashboards in scale for millions of users. So if there is any tool or strategy that can fit this purpose.
Yeah, I wouldn't like, be able to say like, for that like, scale of operation, because like, yeah, because like each of the like, results are unique to like, each of the user, right? So I would guess like, that like this type of things are like, there's like, it's not like, it's gonna run like, like a yearly, like, 1 year it's gonna run all these like aggregation at like a single time. But I would think like, it's something like you would need to like, kind of pre-aggregate like from the beginning, right? And like, you already have this pre-aggregated data, like, and you can just like, display it to the user like it, like, after a year, right? But these calculations were done like, much ahead of time, right? If that kind of answers your question.
Yeah. And just also wondering, probably they don't do that in the last day of the year, right? So you get, as you mentioned in the previous case, you get some dirty reads. So if you, let's say in the last week of the year, you started to listen a lot to, I don't know, Metallica, maybe you will not get that in your top listened artist or something.
Yeah. Yes.
Mm-hmm.
But I guess they using like some mixed approach. It means like some of data calculated daily, and you have daily aggregates, and based on these daily aggregates, you can calculate like in real time whatever you would like to see. It means like you can choose almost like any type of period of time and get any type of statistics that you would like. And moreover, like they have a lot of different dimensions, like how they aggregate this data, because like this data definitely is pre-aggregated. But for example, if you need to get any type of statistic, for example, and some like around like 400 values, like for example, like for each day of the year, it will be like very simple operation, like each system can execute this type of query.
Yep.
Yeah, I mean, I can see that this kind of things depends on some mathematical properties. So depending on the metric you want to show, you can do this kind of tier level aggregations, right? But if you want, I don't know, I'm not kind of a math expert, but if you have something very specific that it depends on a specific function that you cannot like have tiers of aggregations, then it becomes a challenge.
Yeah, it depends. But again, for example, there are a lot of different solutions. Like for example, like there are some probabilistic data types that like used on such scale. For example, like Bloom filter. For example, hyperlog. And all of these like probabilistic data types, like if you're interested, like you can learn, like you can Google about them, and you will find a lot of details, like how it's implemented. Like hyperlog, my favorite one. It's like re-implementation of count, and it runs like much faster.
Good, thanks. So can you write the name of the function just in the chat? So hyperlog you said. Oh, found it. Good, thanks.
Awesome. Any more questions you have, or yeah?
One, two, three, four. No questions. Okay, thank you everyone for joining. Thank you for amazing discussion in chat, like sharing all of books. And Pasang, like like you disappeared. No, like huge thanks to you, like for this amazing presentation, like so detailed, like so fantastic, and very engaging. I'm pretty sure like many people on this call agree. Yeah, thank you everyone. Have a fantastic evening and see you later. Bye.
Thank you guys. See ya.
Thank you guys.
Bye.
See ya.